Just want to remind you really quick of the countercurrent multiplier mechanism. If you remember, as we go down the loop of Henle, we increase concentration before we start to decrease again in the ascending loop. The vasculature there, the paratubular capillaries, are running the opposite direction, so we can maintain a constant concentration. Remember that in the juxtamedullary nephrons, we dive deep into the medulla, and we become highly concentrated about 1200 milliosmolar at its deepest point. So there was a question, I'm sure that Brother Hunt asked, you needed to know about urea. Urea fill the red blood cells so they don't crenate and we don't lose all of our red blood cells in the juxtamedullary nephrons when they get to that high of a concentration. So remember that in the juxtamedullary nephrons, urea is used to fill the red blood cells so they don't crenate and we don't lose them because of the high concentration. That's about all I know from the countercurrent multiplier mechanism. I would know the basis of antidiuresis and diuresis, what is happening there. I would know that diuretics cause a loss of potassium, and that's about all. I wanted to briefly remind you of the three ways we get ADH release. The first one is from an osmoreceptor found in the hypothalamus. In the hypothalamus, we have the osmoreceptors, which are constantly monitoring the concentration, the blood osmolarity. So as we change osmolarity, we can change our release of ADH. If that osmoreceptor shrinks as the concentration becomes greater outside of the or in the blood, then it'll signal to the hypothalamus that we need to release ADH, drop down into the pituitary gland, and we will release ADH in order to increase our blood pressure. For the baroreceptors, they're stretch activated, remember that. So if we increase stretch, we decrease our ADH release. The last one is the renin-angiotensin-aldosterone system. This is one you should be comfortable with. You should know it inside and out. Remember that both angiotensin and aldosterone are released here. The goal, again, is to increase the reabsorption of water, thereby increasing our blood pressure. So these are all used when blood pressure begins to drop, when concentration becomes high, and when it becomes diluted in the blood for the osmoreceptors. Concentration, the osmoreceptors will shrivel, signal that we need ADH, and that will be released. I would know those three, review them, and know them well.